Hello everyone, welcome back to Amin Maths Club. Today we have a nice exponential problem, that is square root of 5 minus x is equal to 5 minus x squared. So we have to find the value of x here. Now starting our solution here, first of all here we see that this 5 minus x is actually, it is 5 minus x. Here it is the domain of this equation, so we are going to check this domain for the solution of this equation. So 5 minus x here, it is actually greater than or equal to 0. So if 5 minus x is greater than or equal to 0, then x will be less than or equal to 5. Similarly, we have this 5 minus x squared is 5 minus x squared is greater than and equal to 0. So x squared will be less than and equal to this 5. Similarly, we have that this x is actually here, this first condition, and it is second condition. So we just write that this x is actually, it is just less than and equal to square root of 5. And similarly this x is greater than and equal to minus square root of 5. So by simplification, the square root of 5 is actually, it is equal to, so x is less than and equal to 2.24, and x is greater than and equal to minus 2.24. So it means that the value of x is valid when x is greater than and equal to 2.24 and x is less than and equal to minus 2.24. So now we are going to solve our problem here. So let's suppose that here we have this square root of 5 minus x, supposed it is equal to y. So y is equal to square root of 5 minus x. Then if we are going to take square on both hand side, then y squared is equal to square root of 5 minus x whole squared. Cancelling square with square root, we get y squared is equal to 5 minus x. So here we have, if we are going to just shift this minus x to our left hand side, then we get y squared plus x is equal to 5. Here we have that y squared plus x is equal to 5. Now substituting these values in our problem, so here we have square root of 5 minus x, and square root of 5 minus x is equal to y. So y is equal to 5 minus x squared. Now here y is equal to this 5 minus x squared. If we are going to just shift this minus x squared, then we get, here we have plus x squared. So here we have 5, then x squared plus y, here we have x squared plus y is equal to 5. So let's say it is our equation number 1, x squared plus y is equal to 5. Here we have now x squared plus y is equal to 5, then y plus x squared, here we have y plus x squared is equal to, this 5 is also equal to y squared plus x. So here we just put this value of y 5, which is y squared plus x. Now shifting these two terms to our left hand side, then we have x squared here plus y minus y squared minus x is equal to 0. By rearranging, then we get x squared minus y squared and minus x plus y is equal to 0. Now here we see that it is x squared and minus y squared, so it is first pair. And here if we just take minus 1 is common, then we have x minus y, which is equal to 0. Now we know that by algebraic identity, if we have a squared minus b squared, it is equal to a plus b times a minus b. So applying this formula here, then we have it will be x plus y times x minus y, and here we have minus 1 times x minus y is equal to 0. So x minus y is common here, then taking x minus y is common, then we get x plus y, and here minus 1, which is equal to 0. Now we have two possible cases, that x minus y is equal to 0 and x plus y minus 1 is equal to 0. So here x is equal to y, and here we have x plus y minus 1 is equal to 0. So here x is equal to y. Now we are going to recall that we have y is equal to 5 minus x squared. Y is equal to 5 minus x squared. Here it is y is equal to 5 minus x squared. So recalling this equation, then we get here x is equal to y, so x is equal to 5 minus x squared. Now here shifting 5 minus x squared to our left hand side, then we get here we have minus x squared will be plus x squared, plus 5 will be minus 5, and here we have plus x is equal to 0. Now by rearranging we have x squared plus x minus 5 is equal to 0. So it is a quadratic equation. We have to solve it by using quadratic formula. So here a is equal to 1, b is also equal to 1, and c is constant, which is minus 5. Now we know that by quadratic formula, that is x is equal to minus b plus minus square root of b squared minus 4 times a times c all over 2 times a. Now putting values, then we get x is equal to minus b, which is minus 1, plus minus square root of b squared is 1 squared, which is 1, here 1 squared, minus 4 times a is 1 and c is minus 5 all over 2 times a, and a is 1. So x will be minus 1 plus minus square root of 1, here 1 squared is 1, minus time minus is plus, 4 times 5 is 20 all over 2. Here we have the value of x, which is x is equal to minus 1 plus minus 20 plus 1 is 21 all over 2. Here we get two values of x. So let's say x1 is equal to minus 1 plus square root of 21 over 2, and x2 is equal to minus 1 minus square root of 21 over 2. Now we are going to solve our second case here, that is x plus y, here x plus y minus 1. So x plus y minus 1 is equal to 0, but here we have this value of y is 5 minus x squared. So now y is equal to 5 minus x squared, then x plus y is 5 minus x squared minus 1 is equal to 0. By rearranging, then we get minus x squared plus x plus 5 minus 1 we get plus 4, that is equal to 0. Now multiplying by minus 1 on both hand side, then we get x squared, it will be minus x, and minus 4 is equal to 0. So here we have a nice quadratic equation. We have to solve it. Now a is equal to 1, b is equal to minus 1, and c is equal to minus 4. So x is equal to minus b, which is 1 minus into minus 1, plus minus square root of b squared, which is minus 1 whole squared, minus 4 times a is 1, and c is minus 4 all over 2 times a is 1. Here we have x is equal to minus time minus is plus, 1 plus minus 1 squared is equal to 1, and minus time minus is plus, 4 times 4 is 16 all over 2. So x is equal to 1 plus minus 1 plus 16 is equal to 17 over 2. Now we have here two values of x. So let's say x3 is equal to 1 plus square root of 17 over 2, and x4 is equal to 1 minus square root of 17 over 2. Here we have four possible solutions of x, but we have to just check our domain here. Then we are going to verify. So for the verification, we have to check our domain, that x must be greater than and equal to 2.24 and x must be less than and equal to minus 2.24. So here we have that our domain is actually, it is x must be greater than and equal to 2.24 and x must be less than and equal to minus 2.24. Now we are going to check here. When we are going to check this x1, so here x1 will be equal to minus 1 plus square root of 21 all over 2. So it is approximately equal to 1.79. So it is actually approximately equal to 1.79, and if we see that this 1.79, it is actually less than 2.24 and it is also greater than minus 2.24. So it is a valid solution. X1 is a valid solution. Now we are going to check x2. Here we have the value of x2, which is minus 1 minus square root of 21 all over 2. Here we will get the value of x2, which is something 2.79, and here minus 2.79 is less than 2.24. So here we don't just consider this value here. So here we are going to just reject x2. So when we see this x3, then value of x3 will be 2.56, approximately equal to 2.56. So it is actually 2.56 is greater than 2.24. So again we are going to reject x3. So when we see this x4, then this x4 is actually, it is approximately equal to, here we have 1 minus square root of 17 over 2. So it is minus 1.56, and minus 1.56 here, it is greater than 2.24, greater than 2.24, and also less than minus 2.24. So it is valid solution. Now by verification, we have two possible solution here. Then our final answer is that x1 is equal to, here we have minus 1 plus square root of 21 over 2, and x2 is equal to 1 minus square root of 17 over 2. So it is our final answer, and we have two valid solution of x. Now we are going to check our entire solution here step by step. So I hope you have understand all these steps. Now it is our entire solution. So that's it for today. Don't forget to subscribe my channel. Thanks for watching. Goodbye.